0.35 kilo per feet. 358 to make it 36. Clear?
مفترض جيب
Got it?
علبة الماء.
Is there any other load is coming? Mufarid. Here. This is any other load which is going to the beam here? Huh? We calculated self weight of the beam. We calculated load from here. We calculated load from here. Is there is any other load is coming here? Live load. Okay. Live load it is coming. So just calculate what is the total dead load. Total dead load which is acting on a beam. Acting on beam. The first one is the self weight, what you calculated 0.14 plus 0.49 and 0.49 plus 0.36. How much is coming? Point 99. So 1 kilo per feet. Clear? This is the dead load. Got it? What is live load? Live load transfer. What is live load? We consider 40 pound square feet. Live load 40 pound square foot transfer from slab 1 and 2 to the beam. How you will calculate?
You substitute the 40 by default.
Huh?
The live load is 40 by default.
40 by default, it is not by default. It is
Because we have
your building is residential building.
we have seen formula for calculating the live load for
No,
homes.
that is the formula. Leave it because they're different. Because we are designing because a roof. We are not going. Our building is one-story building. Okay. So this means very rarely people will go to the top of the slab.
Yes.
Nobody will go top.
Only for the air
So this means
conditioning.
the live load basically it is zero.
So if it's roof,
But it is roof. So roof live load little bit less than the floor live load.
Yes.
Okay, because the roof rarely anybody is going for cleaning purpose. Anybody maybe 2% or 3% will go. Everybody will not go to the roof. Okay, so that is why we are assuming minimum value is 40. We are assuming 2 kilonewton per meter square for the live load. Clear?
Yeah.
Okay. Now here live load which is acting on the whole slab. Got it? What does it mean by 40 pound per square feet? Here it is written now. 40 pound per square feet. What does it mean? 1 feet length, 1 feet width. In this area of the slab, load is acting 40 pound. If 40 pound, how much kg? Could you please calculate?
Google.
40 pound is
Google.
40 pound is equal to kg.
Pound kg.
Suppose this is the slab, okay? This is 1 feet length, 1 feet here. So in this area of the slab, 40 pound is acting. What?
18.14.
18.14 kg.
Yes.
What is your weight? Murtada, what is your weight? 75. So this means at least 1 feet. No, it is not fair. 1 feet is this much. Okay, 1 feet by 1 feet. In this area means 18 kg load here, 18 here, 18 here, 18 here, 18 here. You are considering for the whole 18 area. So this means calculate the full area multiplied by 18 kg. Just consider how much load you are considering. Are you getting?
Yes.
This is 40 pound per square feet. Means in 1 square feet you are 18 kg. You are considering only this area. Though you are considering the whole slab area. 18, 18, 18, 18, everywhere it is coming. It is possible in practical life?
Yes.
No?
In residential building it is not possible. But if it is the just like a theater, just like assembly hall, where all people will come at same times. Then it is fully. That is why we are designing the fully loaded slab. But it is not happening. So suppose if the Khalid will design, the structure will not fail. Why? Because although he designed wrong, but it will not fail. Yeah, why it is not fail? Because he considered 18 for the whole slab load he considered for that design it. Okay? But it is practically it is not happening. Okay? It will come, everybody will come here. But you cannot prevent also if the user will say, no, I want to go, everybody want to go at one time. So this means you cannot prevent it, you cannot hold this load, this slab is not designed for you. So that is why you are designing for a severe loading. Okay, for the maximum loading so that anything can happen, it will not damage. In Turkey, just see here,
Earthquake.
earthquake, maybe 16,000 building collapse. Okay, the huge amount, and they are sending the notice to the builders, and they are capturing. The government is capturing the builder. One builder, I think he designed maybe 10 or 15 buildings, and his building stand like this, and then nothing happened to his building. And other builder designed it is collapsed. So this means they did something under table, over table, here table they did. I think they have compromised the. So that is why they now the Turkey government they are issuing the arrest order. Just catch the builder, because so this means the builder is going here and there in Turkey. They will go to the jail, and then maybe they will spend whole life in the jail. So sometimes you are feeling I am a big mudir, maybe after sometimes you can go to the jail also. Okay? So that is why you have to see. Okay, now done. Live load means here. So live load you have to calculate per meter run. So this means what is the total length? 2 and 1.75. Okay? So what is this here total length?
3.7.
So this means here 3.75 multiplied by 0.04. How much is coming? Are you getting or not? This is pound square feet.
Yes.
You want per meter length, which is coming from the slab. So just multiply by what the length is contributing here to this beam. Half of this 2 meter, half of this 1.7. So this means 3.75 multiplied by 0.04. Why 0.04? Hussain? 40 divided by 1000, this 0.04. How much is coming? 0.15 kilo per feet. Got it? Then what is WU? WU is equal to 1.2 dead load plus 1.6 live load. Just calculate. Now WU, khalas, then design moment, khalas, the beam design.
1.44.
Huh?
1.44.
1.44 kilo per feet. So this means your beam is like this. This is acting 1.44 kilo per feet.
Isn't the 3.75 meters?
Oh, sorry. Yes. 3.75 is the meter multiplied by 3.28 also. Sorry. This is 3.75 is the meter. So you have to convert into feet. Yes. How much is coming here?
0.4.
4. Huh?
0.5. It's 4.
0.5. So just put it here. How much is coming here? 2. This is 2 kilo per feet. Got it? Sorry. 2 kilo per feet. Got it? Now here, just can I rub this?
Yes.
Okay.
I looked up just one question.
Yes.
Chapter 4, we have the 1 minute.
Yes.
I have done it.
So this is 2 kilo per feet the load is acting. This is 6 meter, this is also 6 meter. Clear?
Clear.
Now the moment, calculation of moment.
W.
Calculation of
Mo.
moments. Okay? W negative moments at support. You can write this is A, this is B, this is C. Clear? At support A is equal to WL square by 16. Okay. Here first I am considering, because the maximum is here. So support, instead of support A, I am considering support B. So WL square by 9. Okay. So what is W? 2 L square 6 into 3.28 square divided by 9. How much is coming? Murtada is okay?
Yes.
Because I am giving work for the vacation.
Yes.
Yes, the beam you have to finish in vacation.
Just one question.
Make them leave it, Khalli Balli.
Eighty-six.
Huh? Yes, yes.
86.06.
Huh? 80?
86.06.
86.06 kilo feet. Then calculate Rn. Rn is equal to mu over 5 BD square.
Yes.
So mu is how much? 86.06
56.
multiplied by 12,000 divided by 0.9. B 10 inch. And what is B? D you have taken 14. So D is equal to 14 minus 3, it is 11 inch. So 11 inch square. How much is coming?
948.31.
948. 31 psi.
Go to the table.
What is the purpose here? See, it is more than
190.
912.
Yeah, I'm
More than the maximum.
Yeah, so this means either you can design as a doubly reinforced beam or you can increase your cross section. Okay? I'm not going to design because it's good, I think, if you design is doubly reinforced, design it. This is good. You can design.
After the vacation,
تبي يوصل maybe تسوي تابع.
Okay. Suppose if you are not designing doubly reinforced beam,
You can.
instead of here what you assume, 10 by, I was little bit doubt ki it will come doubly reinforced. That is why I was increasing depth, but you will tell why you decrease. That is why I put it like this. Okay, so that is why if you choose here, assume 16 inch by 12 inch. Okay, then it will come here. So just here 16 inch by 12 inch. So just put it 12 here, and here how much? 16 minus 3. 13 square. How much is coming?
565.
565. Khalas? 565. Okay. Then based on this, you can calculate the reinforcement and all this. So how he did it here, just see. Can I see here is B? Okay. He taken. This is the same just like what you did for each moment. Just you did in the slab.
Yes.
For each moment, you have to calculate Rn and you have to calculate the number of reinforcement. Here you don't have to calculate the spacing. Okay. For each for this, just go to the rho value and then calculate what is the AS is equal to rho into B into D. And then calculate WL square by 14. There are 3 moments here. This moment, so WL square by 9 you calculated, WL square by 14 calculated, WL square by 16 calculated. For each moment you can calculate what is the reinforcement. Clear? Okay. Now here what he did, just I am explaining his design.
This is for the slab. We found 3 moments.
Yes.
Yes. We take it to the
Yeah.
beam. We have to take the total of that.
No, just big moment where it is a big moment, you don't, because here if this is different dimension here, different dimension here, so this moment will be, you can take with the longer span. Okay,
The slab with the minimum span now.
no, yeah, longer span here. Just see here what he did. What he did, first he calculated the H. It was coming 10 by 6, 14. Just see here, assume overall depth is 16 inches here. Instead of 10, 11, he went to 10, and the B he has taken 10 by 16 inch he has taken. Okay, so now just after 10 by 16 inch, okay, he calculated the beam self weight. Okay, then he calculated the wall load. Wall load, how you will calculate the wall load, because maybe in his beam wall is coming. Okay, wall, how you will calculate, suppose I want to calculate, because there is a beam here and then there is a wall here. So I will calculate this width of the wall
And the height.
multiplied by the height, multiplied by 1 meter and multiplied by the density. Okay, this height depends on you, how much you are taking. 1 meter, 1.5 meters or 2 meters is up to you. Okay, so he has taken how much? Here, 4 feet he has taken. 4 feet means 1.2 meter. 1.2 meter thickness he has taken 8 inch multiplied by 145. Concrete density is 150, but the block density is 145, little bit less than the
Because
concrete.
it's whole.
Yeah, it is whole inside. Okay, so that is why here. So here it is load is coming. Then he calculated the total dead load. That is here beam and 1.6 here. He has not considered for the slab because he is designing maybe this beam. Okay, that is why he has not considered. So only he calculated the self weight plus wall load. Because suppose if it is one-way slab, this is one-way slab. If you are designing this beam, then you will calculate the slab load on this beam. If you are designing this beam, then slab load it is not coming. Only the self weight of the beam, and if you are making wall here. Here in this, if in this beam also, if you are making wall, you have to see where you are making the wall at the top. Are you getting or not? Okay, then you have to consider the wall load also. So generally in your plan, whatever the outer beam, you can consider the wall load also. And maybe slab load is coming or not, it depends on the one-way types. Okay, then you have to see whether wall load is. In the same times here he calculated WU, then he calculated here Rn value, it is coming 145 here, it is 145 is coming because he took 16 inches, little bit more, and then slab load is also not coming. So if here it is coming 145, it means he can reduce the cross section. Are you getting or not?
Yeah.
No, you're not.
Why reduce?
He used the dimension because his beam is like this. Okay, he is designing this beam. Okay, in this beam, the slab load here, it will go on this beam. This is in this beam. No load from the slab is going on this beam. Only the self weight of the beam and the wall load which is acting on this beam. Okay, so that is, and the live load, there is no live load also will not go because only the dead load. So that is why here just see the live load, he put it 0 here. Are you getting? Because then if the slab load is not going, so this means the live load is also will not going. Okay? So that is why he put it 0 here and then only dead load, and he calculated it is coming less than 192. This means you can go for minimum also, but it is not a good design. So this means why you provide here 10 by 16 inch to just reduce 10 by 12 inch or 10 by 14 inch and then see Here it is coming maybe more than 192. Whatever it is coming, actual reinforcement you can provide it. You are not getting. Getting or not?
Yes.
Huh? In this way, it is coming 145. It is coming less than 192.
Yes.
So this means that is why he is providing minimum percentage of reinforcement. That is what you have done in slab.
Yes.
Okay?
Yes.
But why it is coming less than? Because he took the depth is coming only.
Dimension more.
Yeah, he took it was coming 10.64, he assumed 16.
Yes.
So why he assuming 16? Just reduce the cross section. So if you reduce this, so this value will reduce. Maybe if it is 10, maybe instead of 16, if he take 12, so this value will come maybe 9 point some, and this value maybe it will cross 192.
Yes.
So whatever the actual reinforcement is coming, provide that reinforcement. So there is no need. Okay, got it? Yes.
It should be more than 192 or less.
It is good. 192. It should be your 192 to 912. Your percentage should vary here in this region. Okay. If any value it is coming less than 192, you have to provide 0.003, because generally what happens in the slab, why it is coming 0.0 less than, always coming less than 192, because the slab, if you reduce the depth of the slab will fail in deflection. Okay, you have to, there are two ways any structure fail in two ways. One is bending moment and shear force, one is in deflection. Slab generally it is resisting the bending moment is easy, but it is very dangerous in the deflection. That is why code says if you are not taking the depth of the slab according to my rule, you have to check the slab whether it is safe in deflection or not. If you are taking our depth, so this means there is no need to check, it is already safe. So that is why generally the slab is higher, thickness is coming, and the percentage of reinforcement is coming less than. Okay, but here the beam, it is not failing in deflection generally. So that is why I should design as a minimum and provide more reinforcement, and our section should be more. So just increase or decrease the section so that our rho value or mu over 5 BD value coming in between, and find the actual reinforcement whatever it is required. Clear?
Yes.
Got it?
Yeah.
Then you will calculate this moment, this moment, this moment. Okay. So for this here, there are 3 sections you have to make. Look, just wait. Now I am going to test you whether you understand something or not. Okay?
Okay.
Clear?
Clear, yes.
Shut up. Okay, this is your beam.
Yes.
Clear? UDL you calculated.
Okay.
Okay?
Okay.
Now you calculated the bending moment diagram.
Yes.
This is WL square by 16, WL square by 14,
By 9.
WL square by 9,
Yes.
WL square by 14, WL square by 16.
16, yes.
Got it?
Got it.
Okay. Now, first you design this beam.
Yes.
WL square by 9, and then Rn you calculated and the rho you calculated. It is coming here. Suppose AS you calculated and it is coming 4 number 7 bar. Okay? You got it for this moment. You got it. You calculated the area and you got it for number 7. I am just going to make a cross section here. This is the cross section here. Here at this supports. Okay, this is the beam.
Yes.
So whether the reinforcement 4 number 7 will provide here or here. This is 4 number 7 or 4 number 7 here I will provide or here I will provide.
Both.
Huh?
Above.
Shadad.
It is in the negative.
Yeah. So it should be the top or bottom.
Here should be in the top.
top. Because the negative moment. So that is why this is the section like this. So this will be here 4 number 7. Got it? Now just come to here.
The opposite.
Down.
Here opposite. But here the moment is 9. Here the moment is 14. So this means the reinforcement will be more or less.
More.
This
But now it's a short
this and down.
Less. Because here the moment is WL square by 9. Reinforcement is coming 4 number 7.
Doctor.
But here the moment is WL square by 4. So it will be 5 or 6 or 3 or 2. If you are providing same number.
Will be more.
Will be more or will be less?
Yes.
Huh?
Moment will be more. Or less.
Less. So area reinforcement will be less.
Yes, yes,
so this
yes.
means maybe here it is coming 3
3.
number 7. Okay.
Okay, doctor.
Got it? Just come to here.
One question.
So, at top.
Here. Top here WL square by 16.
Less.
Maybe here it is coming
2.
2 number 7.
Take the
Got it or not?
Got it, yes.
Got it?
Okay.
Here. Just see here, all are one beam. Okay? So this means if you are providing here 7, here you cannot change the number.
Yes.
Quantity you can change it, 1 or 2, but you cannot change the number. Because if you change the number of diameter, it is very difficult to settle in one beam. Okay, so that is why just if you are finding the area, you have to play in such a way the top diameter should be the same and bottom diameter should be the same. Clear? Okay, this is for bending moment diagram for all these cross section. But the problem is when there is a change in bending moment, shear force will also act. So this means you have to design for the ring also. So this means here there is a ring also here.
And to support the ring, you should
The same number.
Change the arrangement of that. Oh.
Okay, this is the ring you have to provide. This means this 2 number reinforcement. Minimum is here 4, here 2. This 2 number of 7 you have to provide for the whole span.
Not the 4?
Huh?
Not the 4?
Huh?
Without
That is just I am providing. I am not going to construct. Okay.
Why decide to be 2, not 4?
Here, because if it is 4 here,
Yeah.
4 will continue from the all the length.
Yes.
So 4 will come here also.
It should be the.
But it is not needed here. Why unnecessary I am providing for? Wastage of money?
Because it's
Yes.
practically easier.
Yes.
Practically easier.
How we will put it like this on the other side.
Yes,
It will
yes.
be very difficult, doctor.
Yeah, to hold the ring, how many reinforcement is required?
2.
each top.
Only 2.
At least 2.
So just instead of 4 continue, we can provide 2 is a continuous for the whole span. Okay? And 4 will be continuous. So this means the 2 will go like this. Okay? 2 will go like this. Okay? And here it is 2, then it is okay. Here it is, this is bottom, it doesn't matter. Here it is 4, so 2 will go like this.
Oh.
Okay.
Okay.
Are you getting?
Yeah.
Huh? 2 will continue for the whole. 2 here 4, because here we can tell here 4, 4 here. So this is support moment. This here, if you cut a section here, you will find 4 here. If you cut a section here, you will find 2 here. If you cut a section here, you will find 2 here. Similarly, just go to the bottom also here. And here 2 will continue, and here 1 is here for this. So 3 at the bottom, 2 at the top. But here, this area, this 2, this reinforcement, unnecessary you are providing.
But to support.
Yeah, this is not needed.
Support the ring.
Yeah, to support the reading, you are this reinforcement here it is needed. This is needed. But here it is not needed, you are providing. And the bottom it is not needed, then you are providing here also. So this means these reinforcement you are providing unnecessary to the beam. That is why not design as a doubly reinforced beam and take the advantage of this reinforcement and this reinforcement.
And change the dimensions of the
Change the
beam.
dimension, reduce the dimension, and you can achieve the economy.
Make it for the line of steel. It's easier to. What's the problem?
Allah.
If we make it for them, what's the problem?
We have
Here there is a biryani. Here there is a khapsa or whatever. Here there is a
Mandi.
kebab and mandi and that's it. So he will eat always mandi. Whether kebab, if you make it good, he will not go. "Ah, mandi is okay. Easily I can eat it."
No problem.
This is the thing. Okay? Yes. So this means this. You understand the concept or not?
Yes, yes.
So that is why we are designing always a doubly reinforced beam, because unnecessary. Why we are wasting our money to only provide the reinforcement in the compression zone to support the stirrups? Why not take the strength of that, reduce the dimension, and then design it? Okay, so this way you have to design it, and the placing of the reinforcement you have to see. So suppose if here you are providing, suppose here 2 number 8, and here it is 3 number 9, and here 2 number 11. How you will provide here? Here 7, here 8, here 9. Conductor will hold the hand and then he will sit down. What is this designing? Okay. So that is why software design, software will give you like this area it will give you. Okay? Then manually you have to see the design and you have to adjust the reinforcement so that when it will go to the practical field, it will not affect anything and easily you can do it. If you are a very good designer, you will find out the area here, find out the area here different diameter, here different diameter, here different diameter, here different diameter to choose the specific value. Then practically it is impossible to do all these things, because if the 4 reinforcement here with the different diameter, it is a congestion of steel will take place and the proper concreting will not be done and your strength will reduce. Okay? Are you ready? So in this way you can design your beam. Clear?
Yes.
You can design it or not?
Yes.
I found 2 numbers and 3 numbers. How can I adjust the number?
Yeah, that is why here. Suppose here if you find 2 numbers here
Okay.
and here.
And then
No. Here, just see here. If it is, please just listen here. Here. If you find 2 numbers here, diameter is 7. So it is better reduce the diameter here, make it 3 or 4, and then increase the number of reinforcement.
Yes, it will be 4.
But if it is coming here 2 number for number 3, then you cannot do anything because it is a minimum value. So you have to play with this. You have to go with this. Are you getting or
Yes,
not?
yes.
Yes.
You are getting or not?
You
Sir,
got-
I have a question. If we don't have column at the last one, how would
Here?
in the middle?
Middle?
Yes.
So span will be 12 meters.
Yes.
And the moment will be different.
Yes. How?
Yeah, suppose here. Suppose if this is your beam here.
Yes.
Okay? This span is 12 meter. So half load will go from here.
Yes.
Okay? And if there is no slab here, so this means only the load will go from here. Okay? And the moment in this case, because this is fixed beam,
Yes.
I think structural analysis, who taught you? It is not coming.
So can I assist to Khalid? Let's say.
Really?
I Instruction.
Who taught you instruction analysis?
Sayyid.
Section S.
I will give him D grade. I think that maybe I will go to him and ask him why you pass all these students.
You ask
1/3 of the class has failed. 1/3 of the class.
Yeah, I know. I saw 7 and 8 students. The time of checking, I was there.
big boss here. You can't
Here WL square by 12.
Yes. By
This
21.
will be
Why, doctor?
WL square by 24. This will be WL square by 12. This is the moment. How you will go to the fixed beam, analyze it. Fixed beam, because it is a simply supported beam. If you convert it fixed end moment, if you fix end moment, WL square by 12, WL square by 12, and here WL square by 8. So WL square by 12 minus of WL square by 8. How much is coming? Minus of WL square by 8. How much is coming? 12? No. 24. Okay. So this means 2 WL square, and here is 3 WL square. So what is this here? WL square by 24. So this is the here WL square by 24. Are you got it? This is structure analysis.
Minus.
I have a question.
Huh?
I have a question. When he calculated W, he didn't have any life load. Okay.
Yes.
Why he didn't apply the formula which is 1.4 multiplied dead load? Because we have only dead load, and we have the formula for only dead load.
Yeah, only dead load, which is if you are considering, it should be 1.4.
Okay.
Yes, you can multiply it by 1.4 if there is no live load. Okay, you can take it. Okay, so this way you can complete your beam design, and then when you are coming to the next class,